Okay, so starting with the problem statement of this project, the proliferation of fake news on digital platforms has become a critical issue as misinformation can rapidly influence public opinion, disrupt democratic processes, and erode trust in legitimate news sources. The main motivation behind this project is to develop a robust automated system that can reliably distinguish between fake and real news articles. By leveraging machine learning techniques, this project aims to provide a scalable solution that not only detects misleading content but also helps educate users about the characteristics of trustworthy news, ultimately contributing to a more informed society. So, starting with the explanation. So, first step would be importing libraries and setting up. So, in the first step, in this notebook involves importing a suite of essential Python libraries that facilitate data handling, visualization, and machine learning. Libraries such as pandas and numpys are used for efficient data manipulation and analysis, while matplotlib and seaborn are employed to create insightful visualizations that help in understanding the data distribution and model results. So, key machine learning utilities from scikit-learn including model selection, feature extraction, and various classifiers are imported to build and evaluate predictive models. Additionally, the text preprocessing is supported by the and string libraries. Uh, Visualization settings are also custom for clarity and consistency in plots. So, second step would be loading and exploring the data set. So this notebook provides by loading two separate data sets, one containing the fake news article, that is the fake.csv, and the other with the real news articles, that is the true.csv. Each data set typically includes columns such as title, text, subjects, and date, providing a comprehensive snapshot of each article. Initial exploration using commands like head allows for a quick inspection of the data, revealing the structure, content, and any immediate anomalies or patterns. This step is crucial for understanding the scope and potential challenges of the dataset, such as the class imbalance or the missing values. Then going ahead with the data labeling and merging to prepare the data for supervised learning, a new column called class is added to the both data sets, assigning a label of 0 for fake news and 1 for real news. The two data sets are then merged. They are merged into a single data frame, as you can see, which simplifies the subsequent pre-processing and ensures that the both types of article are analyzed together. This unified dataset forms the foundation for all further pre-processing, feature extraction, and modeling efforts. Then going to the next step, it'll be data cleaning and pre-processing. In this step, with the data combined, um, this step is through cleaning pre-processing of the text. This involves converting all the lowercase to maintain consistency, removing the punctuation, numbers, and extra nuances, white spaces, using regular expressions, and discarding any irrelevant metadata. Only the necessary columns Typically, the article text and its class labels are retained for the modeling. This rigorous preprocessing ensures that the text data is in a clean, standardized format, which is essential for effective feature extraction and accurate model training. Then the next step, in the next step, I have done the feature extraction with TF-IDF. Once the text is cleaned, it is transformed into numerical features using the term frequency inverse document frequency, that is the TF-IDF vectorization technique. It's a vectorization technique. So TF-IDF assigns higher weights to words that are more significant in a specific document but less common across the entire corpus, effectively highlighting the distinctive terms that may indicate fake or real news. The result is a sparse matrix where each row represents an article and each column represents a unique word, providing a rich set of features for machine learning algorithm to analyze. Then comes the splitting the data to evaluate the performance of the machine learning models. The data set is split into training and testing sets using the train test split function. Typically, the 75% of the data is allocated for training the model, while the remaining 25% is reserved for testing. Stratified sampling is used to ensure that both fake and real news articles are proportionally represented in each subset. So, this separation is vital for assessing how well the models generalize to new and unseen data. Then comes the model selection and training. The core of this notebook involves training several machine learning classifiers on the training data, models such as random forest, gradient boosting, then the logistic regression, and decision tree are implemented, each bringing unique strengths to the classification task. The models are trained to learn the patterns and features that distinguish fake news from the real news. So, using the TF-IDF vectors as input, hyperparameters are set to optimize performance and training processes in carefully monitored to avoid overfitting. So, after training, the models are evaluated on the test set to measure their predictive accuracy and robustness. Key matrices such as accuracy, precision, and recall, and also the F1 score are calculated to provide a comprehensive assessment of each model's performance. Yeah, the classification report details how well the models distinguish between fake and real news, highlighting areas where improving may be needed. This evaluation step is crucial for selecting the best models for deployment. So, to enhance the transparency and user trust, the best performing model is further analyzed for interpretability. Feature importance scores are extracted to identify which word or phrases most strongly influence the classification decision. This not only helps in understanding the model's reasoning, but also provides valuable insights to the user about the linguistic cues that differentiate fake news from real news. Such explainability is essential for fostering users' confidence in automated system. Yeah. So, in conclusion, this project concludes by summarizing the key findings, emphasizing the effectiveness of machine learning models in detecting fake news based on text features. It also outlines potential avenues for future work, such as incorporating more advanced NLP techniques, expanding the data sets, or integrating additional metadata like source credibility. This project demonstrates a practical end-to-end approach to combating the misinformation, which clear implications for improving information quality in the digital age. Yeah.